All right, thank you very much, and sorry about that. I don't know what happened there with a particular issue with communications, but that does happen on occasion. So if you're holding on still, thank you very much for waiting. I want to talk and thank everybody when I go through this. I couldn't have done this without the team, and I'm not talking about just our training team, but they're just as important. It is the subject matter experts out there that have made this course possible, and I've listed as many as I could pull off right off the bat at this point here. So you can see that, and I see Randy is on there. There's two Randys, in fact, and the rest of the team. And certainly, I'll put this pitch out there. If you are interested in participating, I would be glad to help you along and develop a course. So that's our job, is to develop the course. We have our expertise here that goes along with working with experts in the field, forecasters, and others as well. So let me go on and move forward here. I'm going to talk a little bit. I mean, it's kind of hard to talk about our course just by itself. It would be a little bit dry. So what I thought I would do is kind of talk about some recent events where we applied some of the concepts that we're teaching in the course into it. So some of these you might be familiar with. We just had a webinar just the other day on NBM 3.2 and 4 applications with a snow and winter storm, exceptionally early snowstorm up in Colorado and the central and southern Rockies. And so that's out there, and that's now part of our WOC winter course. There's other topics and other events that occurred pretty recently here, throughout the country, and I'm certainly not all encompassing or comprehensive to everybody's winter weather events, but these are the ones that kind of grabbed my attention. And of course, being here in Oklahoma, I'm a little bit myopic, because when we get winter weather here, that's where my attention is. And so I'm really paying attention to some of the forecasts and the guidance that goes along with it, especially also the mesoscale aspects. I want to talk a lot about the ice storm here that we had in central Oklahoma, and then some subtle after effects as a result of that. There are other things too, like the forecast process. We had Mike Evans and Justin Arnott talk and produce a course just on the overarching view of what the forecast process is in making winter weather forecasts. And of course, it's applicable to many forecast processes, but this is the one we focused on. And so I'll zoom in on that as well. So let's go on and move forward. And I'm going to talk about some other concepts. First of all, I just want to say that we have our WOC Winter page. It's an orientation page. It's called WOC Winter 2021 Orientation and Status. And I put the updates in there as well. There's a QR code there if you want to point your phone to it. I think it will work. And I'll bring up that QR code again later on if you wish. But the whole content, everything else that's in there is going in. In addition to that, I just want to put a couple disclaimers. We have a couple outstanding courses that we have still yet to finish for those students. We're just working through it as time permits to get through that. And I'll tell you, WDTD is quite busy because we're trying to stand up a completely remote rack workshop at this time. And so it's draining a lot of our time, at least, to prepare for that. There's another disclaimer that is some of the courses are in old Flash, so we had to take them off the web, and we're going to produce and republish those as we go. We got literally less than a month to do that, so I've got about 7 or 8 courses yet to go to do that. So if you don't see something on the web, it's because we had to pull it due to Flash. Okay, so timeline so far for the course. So we've kind of knocked off just about everything except those 2 lessons. We have the live webinars that we did, both WPC and the NBM4, and that's in the books and in the course. The simulation is out there. Anybody who wants it, if you're not part of the course and you really want our simulation, we have a mesoscale analysis simulation. And I want to thank the folks in Cheyenne, Wyoming, to help complete that, especially Rob Cox out there. We did it for last year, and then COVID hit, and it completely derailed our plans to get that out the door, but we had it waiting, so now it's out the door. Coming up in January, early January, we have the Snowfall Challenge. It's going to be mostly similar to what we had last year, except there's going to be an interesting twist to that. And when we kind of finish out our meetings about what the nature of that twist is, I'll be glad to share that with you. So anyway, with that to do, let's go ahead and move on and talk a little bit about this. The one thing is a little bit of a story. The timing of the NBM4 was really kind of awkward for our course schedule. And that's because it was coming out, and it came out after last winter. And they don't save any retrospective case studies at MDL, at least making it easy for us to access. So we had to wait for an early snowstorm or some kind of winter storm this year. And when that happened, it was really early. And so I garnered together a team of SUs and forecasters in the affected offices, and we pulled off that webinar fairly early, considering, but who would have known that we would have an ice storm in Oklahoma before Halloween, or that there was a major snow band, snow squall in Iowa in October. And so these are the kinds of things I want to talk about, and also some consequences post-ice storm effects here. So this is what I want to do, and my main points here are to make is that we want to add value to the decisions. In other words, we are not just taking the guidance for rote. We want to look for targets of opportunity. I think that's kind of embedded throughout our course. And our focus also is increasingly on the impacts. So we're going to look at considering varying vulnerabilities and what impacts those have, the rate of snow at critical times rather than just meeting accumulation criteria in our watch warning products. Interesting concepts of the thermodynamics of the surface, societal situations, and so forth. So that's what we're going to be going through, and let's take a look as we go forth. So starting off here, this is in our webinar. In fact, you can go ahead and pull this up, but this is part of David Barchenbrook's component and contribution to this webinar, and that was the issue with bias corrected temperatures in the NBM, especially after they've had such a long period in Colorado of well above normal temperatures. Literally the previous 60 days were much warmer, drier than normal, of course, with all the fires, and then suddenly major pattern change. And what that did is it impacted the bias correction, especially in the longer range, like this is a 60-hour, and it caused a change, an impact in the potential and the probability of frozen precipitation here. Kind of an anomalous decrease here once for the actually just after the onset, and so that persisted for a little while, until the guidance got into the short term. Another one that David put out is, this is an interesting one. Early on, this storm exhibited rather bimodal behavior among all the ensemble members. And because of that, we wound up with a problem when you're starting to look at the means. It's either one set of the solutions or the other. If you take it in the middle, you're going to invoke errors. Of course, the problem is that how do you communicate that? If you try to go for one of the posts or one of the solution sets, you could be way off if it's not turning out to be the case. And so that was a challenge for the Boulder office. And David explained how he started looking at the WPC cluster page and trying to figure out what the nature and the trends of the individual clusters are in affecting the outcomes. So he talked a little bit about that and advocated using that cluster analysis to help kind of unpack the inputs going into the blend. And so that there is available in the NBM4 webinar series. Actually, I made a mistake here. That's not David Barchenbrook's. This is Paul Wolin's contribution from Pueblo. And he advocated looking at the viewers. Okay, so the NBM data and the individual contributions can be viewed in the What's Up viewer and also the 1D viewer. And these tools, he talked about looking over time, and you can visualize sort of like the D-blend DT, so to speak, in trends. In this case here for Alamosa, Colorado, because Alamosa got pasted with a foot of snow during the storm. Literally, that accounts to about 1/6 of their annual precipitation occurred during this one event. And so he's looking at that and looking at the percentile plots of QPF in Alamosa, noting over time how the percentiles are increasing, especially after a certain amount of time, looking at the QPF in the last, I'd say about 2 days where they really ramped up. And so that trend was extremely important. I think that should be the case anywhere, is that we look at the trends there because they have distinct values as well. So anyway, take a look at that NBM4 webinar. We also drew in and pulled in some stuff that from others as well. Dan Baumgart's snow ratio techniques for NBM. What does the NBM do? He has a nice graphic showing how the NBM computes snow to liquid ratios, and as well as the model blends, which models contribute what at what lead time in the blend as well. Okay, so here we are. What did we learn from the Oklahoma ice storm? I'm going to talk a little bit about aspects of the winter storm severity index, how accurate the NBM was, and then any impact-based watching warnings. I can tell you right now, I'll talk a little bit about this, but first let me just introduce this session. This here had multiple forcing. It was a multi-phase storm with 3 different waves of precipitation. And initially, the first wave came out and it was mostly frontogenetical, phased in with a small impulse that came out at mid-levels and rolled out. And then the next wave came in and was strongly warm advection. And that was occurring early Wednesday morning. And then the big wave came out, the whole kit and caboodle came out after that and rolled through. Oops. Okay, so then it came out overall. So yeah, there's the second wave right there, and you can see a strongly warm advection in this warm advection plot, and then over time the big wave rolled out. So this is a complicated event, and throughout all of this, with these different waves, the models had to get things pretty much just right, and they did overall do a generally decent job. So there's that first wave coming in Monday morning. You see the precip fills out. The melting line comes farther and farther south in Oklahoma. Models are forecasting ice and mixed phase precipitation followed by snow. And then the second wave comes in with the southern extent of the melting line at its farthest southern latitude. So it's reached its farthest extent. And then of course, there's the third wave coming, where the Texas Panhandle got pasted with snow underneath the upper level and the PV max. So that's the key things that we'll take a look at here.
Hey Jim.
So yes.
Hey Jim, it's Randy. Can you put it in like presentation mode? We're seeing like a small window and then like all the slides on the bottom.
Oh, that shouldn't happen. I didn't realize that.
No, it's not full screen. Sorry. There we go. Thank you.
Yeah. Okay, so anyway, here we are taking a look at the forecast QPF falling in sub-freezing air but still liquid, if you might say. This is kind of a complicated way to say that that's the QPF falling as freezing rain. And certainly, if we just went with that, that could be construed as an overestimate. We know we use the FRAM model to be more of a statistically based way to estimate how much ice will fall, how much flat ice. And so we'll go ahead and move on a little bit and talk about some of the things involved with this storm. And first of all, I'm going to ping it to our course. And the one thing that we want to make sure that I talk about is that we do have that forecast process course. And so I'm going to start with that. And we start off fairly early in the forecast period. We're checking about a few days ahead, as if I'm walking in here and I'm describing to you what the event is as if we're at shift change. And this is the first steps here is developing the situational awareness. And this is probably a good place where, somebody would come. This is what Mike Evans and Justin Arnott teach in that course, is is developing that essay and making sure that you review the previous products. And so the first product here I'm showing is the ice accumulation forecast that Norman issued, basically that previous Saturday, and they're really hitting this area fairly decently hard, 1/2 to 3/4 inch out in western Oklahoma, west of the city. Norman here, we're looking at 0.1 to 0.25, and Oklahoma City around 0.25 or so to 0.35 and so forth. WPC issued the Winter Storm Severity Index, and they had moderate impacts, I guess, with a small area west of the city with major impacts. And that was due to, this is in fact the overall, but the biggest contribution was from the ice. Okay, so anyway, at this point here, early Sunday morning, the Norman office put out a forecast where they're looking at our current ice accumulation, the highest ice accumulations from near Enid to Kingfisher to El Reno and to Hobart. And areas in northwest Oklahoma should have more sleet mixed in with freezing rain, which results in lower ice accumulations. So at this point, they're really focusing on pinging their greatest accumulations, and they say this, tending to occur where temperatures are around 28 degrees. So this is somebody, as if you're reviewing this in our forecast process lesson, you're seeing what the thinking is ahead of time, fairly early. This is where we think, at least the Norman office thinks, that the proper optimal conditions are for ice accumulation. And then areas northwest up here, farther north and west, should experience ice pellets. So that's a traditional theme, right? You start with liquid, you go a little bit farther northwest and you get the ice, and then a little farther northwest than that, and the cold air deepens and you get ice pellets, and then eventually the cold nose gets too cold to melt anything and you get the snow. And so that certainly seems like a safe bet, notwithstanding anything. Okay, so over time, this is basically now, you're now engaging into the next step here, which we talked about, as Justin and Mike talked about in their lesson. And that's looking at the forecast process. Start looking at the bigger picture. So we have a lesson here. Randy, you're the lead author on this, along with Barb Mays-Belstead, on utilizing impact anomalies to anticipate high impact storms. And so we go through with that. I'm going to share a little bit. I looked at quite a few of the anomalies ahead of time, and I saved this one here, which is actually looking at the M climate return interval from the GEFS ensembles. And the cold air mass, as you can see at 700 and 850, exceed all M climate climatology. So this is just no slouch of a cold event. This is unprecedented in some places. And this is right after we had an unprecedented cold wave in early September in the same places. So you can see in the forecast as we go down through into Monday afternoon, the unprecedented nature of the cold air is sliding now down the high plains all the way into Texas. And that's something that should raise eyebrows, saying, okay, we can expect big impacts that we're not used to this time of year. And certainly, the interesting thing is the Norman office posted the number of times they've, let's say, the frequency in which ice storm warnings were issued. And they found that there has been none issued this early in the season. So anyway, let's take a look at some NBM4 time meteograms, basically for Watonga, Oklahoma. So this is pretty close to the center of where they expect the ice. And I'm roughly indicating where the melting line is, or right here. And you can see the forecast this is from, again, early Sunday. And we're looking at the temperatures dropping by Sunday afternoon below melting line. The wet bulb temperature is what most people use. So I have it here. And the thin line is kind of in between temperature and dew point. And you can see it extends and goes well down. In fact, it goes down to about 25 degrees by midday Monday. So at that same time, of course, the P-type probabilities are peaking for ice pellets in this case with, let's see, this is actually, and freezing rain, as you can see, it gets depressed here, but then peaks in Tuesday timeframe. So cold air is deepest early, and then it kind of gusts out, and you wind up going into a freezing rain realm here for wave number 2, wave number 1 being mostly ice pellets in this case. So needless to say, that's in both of these cases here, there are the phases of the heavy rates, the first wave, second wave, and then the third over here. And the second wave is the one that should be setting up alarms, but the first wave as well, you know, a 30% chance of freezing rain, 60 of sleet. So the accumulations go way up high for all of that. And the other interesting thing is the NBM is putting out thunder probabilities. So that's something that wasn't really considered early on in that early AFD. What is that impact going to have of having convection? Norman, the NBM is much less bullish on getting the cold air in. In fact, wet bulb temperature goes down only for about a 15-hour period here below melting. And in that phase at that time, you can see this is after the first wave. So the first wave is going to be mostly liquid. The second wave is where our concerns come in, that we could start incurring ice accumulations at that point. So over here, you can see that the probabilities for ice, if we look at the freezing rain accumulations, is here and here for the 6-hour accumulation. So it's not a 0% chance of ice because, again, this is a, basically a mean forecast temperature. So some of the members are coming in colder. So anyway, we got that, and let's move forward and talk a little bit about what's going to happen here. And so we have the first HREF coming out midday Sunday, and you can see the precip starting up. And then the ice starts coming in, but it kind of holds off. So we don't get any ice of any form in the HREF, according to the mean p-type, until the second wave comes in. And then it's all ice there. But at the same time, if we look at the ensemble mean, most unstable cape, here it comes. All right, and slides up high enough to include us for at least the first wave. Right there, early Monday morning. The cape, the MU cape, then in the mean tends to retract in later periods in this forecast here. So it's Sunday PM. This is an AFD, and at this point, this is when forecasters start looking at some thunderstorms may even be possible across southeast Oklahoma. All right, but they're sticking with basically the same traditional scheme of sleet in the middle of the snow and the freezing rain. All right, and then we come to Monday morning, and here we are. The morning sounding shows substantial elevated instability. So, the forecasts were correct, and indeed we did wind up with a band of thunderstorms that came through, and ice pellets, of all things. Temperature is roughly now about 33 degrees. And suddenly the scheme of having the traditional freezing rain southeast of the sleet completely falls apart. So the amazing thing is, and in fact, this continued, you may wonder, by the way, this video is taken around 2 p.m. and the sounding was at 7 or 6. And here we are with the line of thunderstorms, basically a stationary line of storms, very convective, continuous train echoing, and the temperatures are dropping close to freezing. So at that point, we wound up with just about every type of precipitation. Our temperatures were still technically too warm to accumulate ice at our place here. And so the ice pellets were actually occurring southeast of the freezing rain. So the one thing that's kind of interesting, if I look at the HRRR, and if we look at the HRRR, you can see that indeed the analysis, and this is a 12Z, matches pretty close to what the actual observed sounding was for here in Norman. And each forecast after that, if you see, washes away the instability. So here's the 12Z forecast, and now the 6-hour forecast, pretty close to the video time that I have. So it tends to cool off the warm nose quite a bit when we're getting sleep, but of course it destroys all Cape. So there shouldn't be much in the way of a line of thunderstorms going overhead. And that's certainly not the case. And then when we go to the 18Z HRRR, it kind of partially restores that sharp warm nose and restores the elevated instability. So definitely have a situation here where the observations are not fitting with the short-term guidance here, at least with respect to the HRRR. And so there's a lot of confusion going on here in the midday. If you think about this is now in the realm of a mesoanalyst at this point. You are now getting and having to explain unpredicted ice pellets in places, and how long is that going to go, and what impact is that going to have? And so at this point here, the thinking shifted suddenly and very immediately from, okay, it's mostly mostly rain with the freezing line coming down, and then we get mixed to the point where we're getting large amounts of ice pellets, and now that's going to impact the road because now it's drawing heat from the road, and the ice pellets will cool off the roads to freezing very quickly and result in slick roads. And so the theme has changed quite a bit. Also, they were worried about if some areas not technically achieving a 1/4 inch of ice to satisfy an ice storm warning. But they decided, well, we've already put one out. They put one out early Monday morning. And at this point, it really doesn't make any sense to suddenly go backtrack off of that back to a winter weather advisory when they know they're going to get phase 2 and potentially phase 3 of ice. So they just simply went, throw our hands up, let's go ice is ice, whether it's sleet or freezing rain, we're sticking with the ice storm warning. In the end, it's all hazardous weather. So relevant forecast problem here. Well, we do talk a little bit about that in the P-type forecast methodology that Todd Foisey put up in our WOC winter. Clearly, this is also a mesoscale analysis and short-term forecasting issue. And in fact, one of our cases talks a lot about looking very carefully at the steeper lapse rates aloft and making sure, what is the forcing mechanism for generating those steeper lapse rates. And so this is the mesoscale, of course, down here. Up here is the other one. And in fact, we do talk about this, is that, if you wind up having precip rates much higher than expected, obviously convection does that, that you can allow, for, it wasn't just ice pellets, it was hail as well. Plenty of species can make it through that warm nose and then down through there, and that's what happened there. Plus, we were just 33 degrees at the surface, but we had a steep lapse rate, and just off the surface, it was sufficiently cold for refreezing. So anyway, that was the one challenge there. The other one, of course, is what's the total ice going on? So another early forecast looking at the KOUN NBM from 01Z Monday forecast, and we're looking at the probabilities here in a box and whiskers plot with the shaded area in the 10th and 90th zone. There you can see the 24-hour freezing rain is about 0.1 to 0.4 and so forth, with the 50th at 0.3. So we'll see if that follows suit. These numbers are fairly consistent for us, if I picked other hours and so forth. If I look at El Reno, this is very close. Here you can see values are higher. Air is colder, longer periods of time below the wet bulb temperature, fairly cold. You can see that the obs, though, were even colder than the blend, which is not surprising considering the shallow nature of the Arctic air. So now in this case here, we have 2 periods of 24-hour totals, each one potentially satisfying an ice storm warning. The first one there, as you can see, well in excess of ice storm criteria. So the ice storm forecast that Norman put out Monday, they've updated it. They've increased the totals generally. Now, we got the 0.5 to 0.75, but with the colder air farther south than some of the guidance, they increased the totals into Norman as well, exceeding ice storm criteria. So they're already outlining ice storm power outages and so forth. How did the WSSI do? Okay, here's the early forecast on Sunday. And you can see that it goes up to a small area of major, but mainly west of the city. Later update on Monday. Now the ice is going farther east. Again, all of this is off of the NDFD, and so you can see the emphasis is higher and stronger in here. It goes up to major impacts. And what does that mean? Extensive property damage likely results in major disruptions. I'll tell you one thing right now. I'm trying to start my generator, and it's not working, which isn't great. And so what are the impacts? Significant impacts everywhere. Much more dramatic than we've seen anything since 2007. These are pictures, videos of my backyard. I had tree limbs coming down like crazy all morning, including some that drove wooden spears into the backyard. And the total accumulation was about much more than actually forecast, 1 to 2 inches across El Reno, northeast to southwest, here in Norman, close to the half-inch mark. So again, a rather substantial amount. The result was widespread and extensive power outages. These power outages just didn't last a day. I think the forecast was right on, the ice storm warning mentioning how long it could last, up to 5 days and so forth. And so here we are on October 30th. There's the VIIRS nocturnal visible imagery. Now look at what happens when we recover. And to November 5th, you can see a lot of energy or power coming back. And you can see, especially in the towns up to the northwest, where they got hit really hard. But here as well, we just got slaughtered. There were people without power for 2 weeks in the city, and not just a minor number either. So at this point, I'm going back and looking at, okay, there's the worst of it right there. It even shows up in day cloud phase. There are accumulations that equal Coke can sizes out here in the west. And you can see that, you know, radial accumulations involved huge numbers of icicles that contributed a lot to the weight. It's not something that's really accounted for in any of our models and prediction models, is the number of icicles that form on power lines and so forth. So, you know, is the WSSI accurate? Is major enough for something like this? The power outages were equally as bad as they were in 2007, even though the last one had more ice and was later in the winter. And of course, it's because of the foliated deciduous trees. Rather subtle accumulations led to huge impacts around here. And it's not something I think that's really accommodated for in our impact-based in the WSSI. Of course, somebody could correct me. Usually, I know WSSI includes forest type and so forth, but it's the phase of the deciduous trees that's really a key thing. So that's something to think about here, is that, you know, even with, and no doubt they passed ice storm criteria, but the impacts were worse, I think, than a marginal ice storm warning criteria, in other words. So that's something that we're thinking about. Everybody was thinking about that ahead of time and so forth. So yeah, absolutely huge impacts. All right, it's 10:46. So let me go ahead and talk about some other things here. We had some consequences as a result. We had a windstorm event coming down, and this helps kind of highlight two lessons, or one major lesson that we have, and that's Paul Nutter's with Hannah White on forecasting severe winter winds. And so one of the things that I'll highlight, especially in their lesson, is the mechanisms for generating high winds, and Paul does a very nice job in describing those conceptual models. In this case, I'm going to just highlight rapid pressure, in other words, isobaric forcing, like in strong fronts. And also, he talks extensively about the NBM performance with winds. So we'll take a look at that. And we had a cold front coming. So this cold front was much stronger than actually predicted. We had all the power back on, and now we have this strong system going through the plains just a couple days ago. The cold front's forecast for Saturday evening. So initially, November 12th, a few days ahead of time, okay, we knew ahead that we would have strong prefrontal gradients and the wind gusts would go up, and you can see that the upper extended envelope of the standard deviation of the wind forecasts is roughly 30 to 35 miles an hour. The observations, well in excess of that. And then a secondary peak later on had winds close to 50 miles an hour. But at this time, the NBM is just not resolving the front. Different timings, it would be different resolutions, especially with the longer range guidance, a bigger part of the picture. If I look at the HREF, you can see that there's the gradient coming in, and then we have 40 miles an hour winds. This is from November 13th, so now we're looking at a 24-hour lead time, actually about close to a 30-hour. And so we had the initial winds with the prefrontal, southwesterlies, and then here comes the front, and the front hits us in HREF. I'm using the ensemble max gust here, by the way, which is kind of like a reasonable worst case scenario, indicating greater than 40 miles per hour. More recent NBM, now this is November 13th at 18Z. All right, we're roughly on that day of notice. And now it has a much stronger secondary peak with the front, but of course still well short of the obs. I think the important thing is getting the trend there. So now we're on November 14th. We're less than about a roughly 12-hour lead time. And at this time here, right there is where the front hits, and the ensemble max gusts are hitting on areas close to 50 miles an hour. I mean, it's getting fairly close. So I was impressed. But of course, I had to go with the ensemble wind gust max at that point. If I look at this one here, again, it's, the gradient wind is, of course, less of a peak there for some reason on the 13Z, but by the time the 19Z comes back out, there's more of a peak here. So this is on the final hours, right? And, we're still looking at well short of what we want. But I think the important thing is overall, it's got that peak. You're just not going to get the absolute magnitudes. These wind gusts and winds are on the hour. They're not looking at the peak in between. And plus, the general, when you're using ensembles, there's some shortage right there. So I think the key thing here is, looking at the HREF individually, I think is still important, and looking at the applications. We do have a couple lessons on that. Two of them are comment lessons on using the cams for winter. So as it turns out, in the mesoscale and mesoanalysis realm, if you look at this, you can see this front coming down. It's got a haboob with it, very sharp front end, something that just wasn't resolved as well as could be in the model output, especially in the blend. So that should be an alert right there that maybe we need to do something. Now, we did get a wind advisory out here. Our wind gusts went up to 50 miles per hour following the front, and 45 to 53 here in Norman at this point. I can tell you one thing, I was thinking ahead about this too, because my son and his friend wanted to go camping out in the backyard, and I said, do not camp under the trees. Move your tents away at this point. And also, in addition to that, we had serious impacts. Usually 50 miles an hour doesn't do anything around here. We wound up with power outages that exceeded 12,000 in the same places. And the reason is that we had all these hanging tree limbs. I didn't have to look very far to see a couple good ones. This is in our backyard, our neighbor's yard, with a massive hanging tree limb. Here's another one example. That's a small one. A lot of them were hanging over wires. A lot of the wires are patched. And so that's something that resulted in a secondary impact because of the ice storm. So our vulnerability was high, and maybe this is kind of a case for a high wind warning, all right? And maybe the winds don't quite meet threshold, but then again, our threshold for causing additional power outages was much lower than before. Okay, all right, final case here, and then I'll close down. And this one here was the Iowa snow ban back in October 19th. An exceptionally early time of year to get 7 inches of snow. There were lots of accidents throughout Des Moines. Some of you might have remembered this one. And there's the video loop of the snow band going through. This is the composite reflectivity. It was intense. It was an intense snow band. And in fact, the GOES GLM product flags a couple flashes right there just east of Des Moines during the height of snow band. So vertical velocities were easily capable of splitting charge. So not a minor event, at least in this case here. This is a rather significant one and poorly forecast. So no guidance forecast came close to what fell. The AFD in the morning understandably had less than an inch. There wasn't any guidance anywhere near to what fell. And I'm looking at the loop of her visibility, and you can see it's diminishes. It's more intense in Nebraska, and then it just falls away as it goes through Iowa, and almost no accumulation. So the thinking was exceptionally early time of year. The roads should be easily warm enough to melt anything that falls, and so it's not a major significant impact. Yeah, I know it was wrong, but this happens. This is now, you're not in the realm of prediction. You're at the point where you have to decide where to react when things are falling off the rails, so to speak. It was a frontogenetic event. It was very clear that it was, but this is a model forecast, and this model forecast also way underdid things. So the magnitude of the frontogenesis is likely much stronger than what's depicted here. So the first reaction that Des Moines did was issue a snow squall warning. I've kind of poured over the chats and so forth, and literally they were reacting because you know, there wasn't much communication until a certain point where, you know, the conditions just caused them to just break forth and do something about it. And so this is what they did. And it's interesting to see. It is a snow band. Is it the kind that fits a snow squall warning? Well, we got 3 lessons here to describe that, courtesy of Pete Benakis, Greg DeVar, Andrew Lacanto, Dave Nicosia, and Jared Klein. So we just have the newest one out this year. And in the newest one, they've had a couple of years of learning what snow squalls look like. And there are 3 different conceptual models, including a rather unique one here from an earlier event last year, which is an elevated QLCS, a kind of QLCS, snow QLCS, that would not appear in the snow squall environment product, the analysis that depends upon sharp and steep lapse rates right to the ground. That did not exist for this one, so they call it an elevated QLCS, but basically conditions on the ground are the same. High winds, rapid decrease in visibility, and potential for flash freeze. Okay, so and still this band moved, you know, the one that they depicted here is elevated, you know, moved rapidly eastward and so forth. So it fit the model. But this one's different. This is acting more like a traditional frontogenesis band that's basically train echoing and dumping several inches of snow. So it's not a quick burst. So technically speaking, excuse me, it's not a snow squall, you know, for which the SQW product is intended for. But does this event match the same urgency? And so I'd like to say that I'm going to go ahead and acknowledge Kelly Butler here for a talk in NWA. Also another talk, forgot the name, but you can get it off the visit page here. It's at one of the satellite webinars. And Wichita area last year, they had a similar band that dropped almost 10 inches of snow within an 8-mile wide zone, but similar qualities and similar behavior. And honestly, they were very tempted to issue a snow squall warning for this as well. I think they held off, made a winter storm warning, and then when one of those bands started reorienting and acting like a traditional snow squall, then they issued one. But this one here, you can see it's very attractive. The snow squall warning has something of the WIA alert, okay? Winter storm warning, no, nothing else. And so they went with it. I could understand why. It had the you know, all the aspects that they wanted to get out, was the emergency and the reach of a product, because they were in trouble, basically. Okay, so with that in mind, I'm going to go ahead and just kind of end with a couple things here. And one is a really apt cartoon from forecaster in Portland, Margaret, I think. Her handle is in Twitter is Cooking Up a Storm. And I thought this is really apt. She made this to encapsulate the desired NBM forecast workflow. And this is something I think Chad Gravel was involved with as well. And I thought it really works well, because it works well with our forecast process lesson. You know, looking at putting the NBM in its place, using it as another tool, not depending on it, thinking about this in the term of the greater need to create a conceptual model, looking at the output and the possibilities out there, how rare it will be, and then thinking about the NBM for the particulars, and then looking for those targets of opportunity to make improvements on it. So part of a process, and we described this as well, you know, in this lesson here. So with that in mind, closing points. Okay, there's the QR code for our course status page. Keep that up in mind. We will get those last 2 lessons out. The course runs for a while, though. You got plenty of time if you're a student. And we'll have SRT availability. That's the seasonal readiness training as new lessons arrive. And also think about, we'll have that snowfall challenge coming up, and we'll make an announcement and send to all offices. So with that, I'll go ahead and close, and I'll entertain any questions there that you might have.